Now let's look at scheduling criteria for scheduling jobs in machines. And there are basically two main criteria. One is to keep the inventories low. The second is to meet customer delivery promises. So these are the two overriding criteria for scheduling jobs into machines. And these can be broken down into four criteria. The last one, minimize customer wait time, that being meeting the customer delivery promises. And the first three, 1, 2, and 3, they are related to keeping the inventories low. Minimizing completion time. So if you complete the jobs early, then you are able to get it out of the production facility. So that results in reduced inventories. Maximizing utilization of facilities again means that you're completing the jobs as quickly as you can. And of course, WIP, the work in process inventory minimization, is what the first and the second criteria tend to support. Now, in different production processes, you need different types of approaches. If you look at production facilities, we can classify them into three major groups. One is job shop. Job shop is where you will have highly skilled labor but general purpose machines. So when customers place order, then the highly skilled workers will manipulate the general purpose machines to produce products that meet customer specifications, whatever they may be. So very high level of customization is involved in this environment, and typically orders are processed after they are received. So that's what job shop will be like. In this type of environment, you will have lots of variety of jobs, but each job will have low volume. So low volume, high variety. So scheduling in these instances is often based on due dates. Of course, you want to meet the due date, and you also want to make sure that the capacities are sufficient because it's highly skilled labor involved. So finite loading techniques are used. Now, the second environment is repetitive facilities, and this is where you have fairly narrow range of products, and those products are produced in an assembly line. So since this is narrow range of standardized products, you will have high volume. High volume, relatively narrow range of product lines. So schedules here would be towards the modular production modules to be produced. It's like assemble to order. We discussed assemble to order in the previous chapter. So the schedules are made for the modules, which are then put together into various product lines. And typically just-in-time type of techniques are used in this kind of environment, where when there is a need, the production of the components are initiated. When there is no need, you don't produce those parts. Now the third category is continuous production, where here in this environment we have very limited variety of products and huge volume. So oftentimes this will be continuous production, like paper or steel sheets or carpet in our geographical area. And in this kind of environment, since the volume is high, very limited variety, we have to make sure that we have stable demand and we have fixed capacity, and make sure that we produce within the fixed capacity. So finite loading is what is generally used. Now here are the three different environments that we talked about, where the first one is your job shop. We have a few inputs and you have large variety of output. So here are some examples of that environment. And then here we start with a large number of inputs and produce a fairly few modules, and the modules are then assembled into a wide variety of of products. And in continuous environment, we have very narrow product line all the way up to the last stage, where during the time of packaging, fairly medium level of product lines are produced based on a very, very narrow set of inputs. Now, when we look at the job shop environment, the first one in the previous slide, scheduling process for focused facilities. So we have high variety and low volume. The production differs considerably from one order to the next. So scheduling incoming orders must be done without violating existing constraints, and the scheduling here tend to be complex because each production order coming in will require a different flow through the production process, because it requires different set of production processes in different orders, so it becomes really complex. Loading jobs is to assign jobs to machines so that the cost and idle time and the completion time are minimized. So there are two forms of loading. There's capacity oriented loading, and then assigning specific jobs to work centers. Now when we do this, we can use what is called input-output control charts to monitor the level of input coming in, input meaning the jobs that are assigned to the machine, and the amount of output going out. And what are the planned inputs and what are the actual inputs? What are the planned outputs? What are the actual outputs? And is there a backlog developing? So we can use this input-output control chart to monitor what's happening in a production workstation and take corrective action if there is backlog developing or if there are any problems. One of the things that go with input-output control is called CONWIP. And CONWIP refers to constant work in process inventory. So you have a CONWIP card at a workstation, and once that job is completed, once that amount of work in process is completed and moved away, then this CONWIP card is released, so some more input can come into this workstation. So this way you keep the work in process inventory at a given workstation at a constant level. Now let's look at an example of input-output control. So we have input-output control on a weekly basis, and it is rolling time. That is, as 1 week gets into the past, a new week into the far future is added. So we have one table for input, planned, actual, and cumulative deviation between the planned and actual. And then there is output, planned, actual, and the cumulative deviation. And then there is cumulative backlog. And here in this slide, they're talking about change in backlog, but we will calculate the actual backlog when we work out an example in just a second. So now when we look at this chart, we can see how the input is doing when we look at the cumulative deviation of input over time. Is it going more than what was planned, or are we having less than what was planned in terms of the actual input? And similarly output, how the actual outputs are doing with respect to planned outputs. And then there is backlog. We'll talk about backlog when we work the problem out.